Okay, so what I want to talk here a little bit is I just want to remind you what you already know about fractions. So remember that a fraction is a rational number, and so this basic fraction is also a rational expression. We just don't think of it that way. And I want you to really understand why I'm kind of joking a little bit in saying that when we talk about multiplication or division of rational expressions, why we also kind of call that simplifying. Okay, because we're really doing the same thing, because technically I could say 7 times 3 and I could say 9 times 14, but that creates math that's much more difficult, right? I multiply fractions, I multiply across the top and across the bottom. But since whatever's in the top is multiplication and whatever's in the bottom is division, then I can also simplify first. So instead of saying 7 times 3, I'm going to say, oh, 3 goes into 3 once, 3 goes into 9 twice, 7 goes into 7 once, 7 goes into 14 twice. And now that I've simplified first, I'll go ahead and carry out the multiplication. That's 1 over 4. So that's why you can call this simplifying rational expressions, or you can call it multiplying and dividing. Now, are we going to have things so simple? No, you're not a third grader, right? You're in high school. So what we're going to do in this unit is we're going to create more and more complicated polynomials in our numerators and our denominators. So I'm just going to kind of make this be very similar, 7x squared over, let's say, 9y cubed, and then times, I don't know, let's keep the 3, let's make this be y squared, and this be 14x. So I took something that was just a simple multiplication problem of a fraction, and I turned it into a slightly more complicated rational expression, but the same things are going to apply. You could start multiplying all of this stuff, right? I could say 21x squared y squared, and then I could do 9 times 14, but I don't want to do that. Those are making bigger numbers where I don't need to. I'm going to basically do the same thing I did here. 7 goes into 7 once. Oh, I got a cool triangle. I don't want a triangle. Let's make the triangle go away. There we go. 7 goes into 7 once. 7 goes into 14 twice is same. But now x squared, there's 2 x's on top and 1 on the bottom, so I can bring this down to x to the first, which of course we don't write anything at all. And this x now is canceled because x divided by x makes 1. And then I can do the same thing over here. I can say 3 goes into 3 once, 3 goes into 9 twice, and I have y squared on the top and y cubed. So that means 2 means if I have this and this, right, 1, I just have 1 left in the bottom. So this is gone, and this is a 1, which I don't need to write. It's just a y. So what does this look like when I'm all finished here? Well, I have just an x in the numerator, right? That's all that's left. And in the denominator, I have 4, and I still have a y left. And if you really wanted, you could put a 1 here, but you don't have to. All right. And if I change this to division, right? Remember, what do we do with division of fractions? And if let's say I have 1/3 divided by 2/3, right? Well, division of fractions, what did we do? We took the first fraction and we rewrote it, and we said multiply, and then we flip. So again, oh, I need a 2. 2/3 becomes 3/2. So now again, 3 goes into 3 once. I'm just left with a half. And we can do the same thing. We're going to see. We could do this if we have really complicated. So I could have something like x plus 3 over 3 times x minus 1 divided by, we had that 3 there, so let's say 3x plus 3 cubed divided by 2 times x minus 1. And I would still set it up the same way. First fraction stays exactly the same. Second fraction, I have to turn over. Okay, and now I start going into that canceling mode. Oh, there's 1 of these up here. There's 3 down here, so now there's 2. X minus 1 divided by x minus 1 means they cancel. And now what's left? I have 2 times 1, which is just 2. 3 times 3, which is 9. And I end up with, I still have that x plus 3 squared. Okay, so we're going to try to use what you know about multiplication and division of fractions, and we're going to apply it to